for work example 2G, yeah, from what you might have already learned about from your textbook, I want to add some explanation to make you more understand. Firstly, in this question, we are talking about free falling object without air resistance. So it's really free, completely free falling object. Now, what is working the object is a constant acceleration of 9.8. What is this? Gravity. So gravity pulls down the object, right? Now, this gravity 9.8 become the acceleration in free falling, because free falling means going down, right? So the gravity that works, yeah, or usually rounded to 10, yeah, 9.8. So usually rounded to 10, but yeah, it's okay. Now, and there's question A, B, C. You can already see in your textbook. Now, you can find this graph in your textbook, right? Speed time graph. Now I want to explain about this. Why is it a straight line? It's a perfectly straight line, right? Why is it? Because look at how we read this graph over time. Sorry. Over time, the speed will be increasing, right? It will increase. It will increase at a same rate, yeah, increasing at same rate. That's why the graph is increasing but linearly, so it's straight now. And then remember, there's speed time graph and distance time graph. How if I want to represent the distance time graph? It will be like this. So in distance time, it will be this. Why? It is really easy to understand this. With increasing speed, that means over time, the covered distance will be more and more far, right? For example, from here to here, the distance just go up like this. From to here, just already go up like this. From here, the increasing like this. Here, the increasing is like this. And here, the increasing is like this. So after a certain amount of time, the distance added will be so much, because the speed is really high already. Yeah, make sense? Now, I hope this makes sense to you, and after that I'm gonna discuss the answer with you. Now, speed. Now, if you look at the textbook, there's a working, there's a solution there that I don't really use. I always use this formula. Velocity equals gravity times time. This is just for free falling object. Gravity times time. 9.8 times. The time is 1.4, right, from the question. Look at that again. I believe this is much shorter and much easier to understand. Yeah, if you compare to the textbook, it's just the same answer. For B, they ask for the height. The total height from the object start to fall until it reaches the ground, right? So height or total distance traveled from this to here to the ground. Now, we can use this formula. So the height is 1/2 times velocity times time. This is okay. I was gonna say something, but yeah, it's okay. Yeah, this no more explanation needed. Just follow this. Velocity you have already from here. Just put in the time. Done. Now C. The question was like, if there are two objects that have different mass, will there be different effects on the speed? Will they reach the ground in different time? The answer is no. The reason is both have constant acceleration, 9.8. Again, 9.8 is the gravity. the gravity of Earth. In free falling objects, yeah, in free falling motion, the gravity becomes the acceleration. Now, no mass, mass is not the factor for to determine like how fast an object gonna fall. Yeah, so because any object on Earth will have the same gravity force, so that means every object will fall, yeah, the same, regardless of the mass they have, how heavy it is, because mass don't work. No mass, there's no mass in the formula, right? No m, right? So mass is not a factor at all to determine all these numbers. So the speed will be the same. Okay, I hope you understand that. And if you still don't understand, you can ask me in the chat. Yeah.